Hello, calculus fans. We have a lot of differentiation formulas for real-valued functions. Things like the product rule and the chain rule and the quotient rule. They have counterparts for vector-valued functions. So, for instance, if you have differentiable vector functions and a scalar c and f is a real-valued function, then here's a whole bunch of differentiation rules. The first two are pretty clear. If you differentiate a sum, you just have to differentiate each piece. You can pull constants out of derivatives. Starting with the third one, though, it starts to get interesting. You have a product rule. You also have different types of product rules. You have a dot product rule and a cross product rule. And then you have a chain rule. Now, just as an example to see how you might use these, let's show that if you have a vector function where r of t is a constant, then r prime of t is going to be orthogonal to r of t for all t. Okay, so we know that r of t dotted with r of t is just a constant. That constant is c squared. We're going to use the dot product differentiation formula. Let's see what we get. So if we differentiate both sides, we get 0 is equal to the derivative of r of t dotted with r of t. Now comes the dot product differentiation formula, the product rule. So we get r prime of t dotted with r of t plus r of t dotted with r prime of t. Or 2r of t dotted with r prime of t. So now we know that r of t dotted with r prime of t is 0, and that tells us that r of t is orthogonal to. So the geometrical interpretation is that if a smooth curve lies on a sphere centered at the origin, then the tangent vector is always perpendicular to the position vector. Okay, that's all for now.